Good afternoon. Welcome back to our S black elements, and we have seen what are the S black elements. That is the lithium family: lithium, sodium, potassium, rubidium, cesium, francium, and beryllium family: beryllium, magnesium, calcium, strontium, barium, radium. Francium and radium are the radioactive elements, and then we have seen their reactivity chemical properties. While seeing the chemical properties, reactivity with the that is normally with air. Air means lithium plus oxygen gives lithium oxide. And if you see the sodium plus oxygen, we already seen that it is normally sodium oxide. So there is a sodium peroxide also, Na2O2. But other metals will be the superoxides 1 in or 2. Worry about the this one what you call oxidation state of the oxide. Only you have to keep the oxidation state for the metal only. This then metal plus water reaction is tremendous reaction, that is metal hydroxide will be forming, and hydrogen will be released. So this will be kept in the water. So sodium and particularly is very rigorous, so it should be showed in normally in the kerosene. Potassium also like that only. Reaction with the metal with the hydrogen, reaction with the hydrogen gives the metal hydride. Some interesting hydrides also will be there, high with a high melting point and all. Lithium is only smaller. The reaction with the halogens is metal plus halogen. Halogen X gives the Mx. That means HCl. What do you call? No, it's not a HCl. It is a sodium chloride, potassium chloride, and all. Sodium chloride, potassium chloride, rubidium chloride, lithium chloride, cesium chloride. You can go ahead. They are all high reducing agents. High reducing agents. So because their hydration enthalpy is more, so they will form the what you call good this thing. They will react. They will soluble in ammonia. So these are some of the this for any matter, any this thing. Normally it will be reaction with oxygen, reaction with the halogen, reaction with nitrogen, reaction with hydrogen. Like that, this will be the common general. So one should remember that any chemical properties means start with oxygen, nitrogen, halogen, and then reducing properties are the oxidizing properties. Then it will be the hydroxides or oxides, reaction with the metals. Like these are the some 5 6. So one has to by heart only. There is no other go and remember. Now uses are more and main this thing. First use with lithium. Lithium will form along with alloy. So many this is called lithium alloys are with the white metal, they are called. Many white metals will be there, don't get the confused and all. Lithium alloys are some white metals and useful in bearings, particularly bearings of the ball bearings, and in the motor engines, and 2-wheeler, 3-wheeler, 4-wheeler motor engines. This is the white metal. White metal in some other people have a wrong idea when silver metals are called white metal, aluminum, some direct metals are called white metals. No, lithium alloy. Lithium will form with the alloy. That is called white metals. That will be used in bearings, particularly motor bearings, ball bearings, and normal bearings also. Then lithium with aluminum, lithium plus aluminum alloy will be used in aircrafts. That means lightweight, strong but lightweight. Lithium aluminum alloy, very useful engine. Lithium with magnesium alloy will be used in the armature plates, armor plates, and in the tank crafts and all these things, chains and all these things. and even the lithium is used in thermonuclear reactions also. That will be we will talk later. And sodium and lead alloys. Uh, this is also another alloy, useful alloy. Sodium is directly useful in what you call nuclear reaction, nuclear industries. It is called the coolant. Normally, metal coolants are very rare. Only sodium is the metal coolant that is in the fast breeder reactors. Sodium is in the nuclear industry as a coolant in the fast breeder FBR, fast breeder reactors. Test reactors for FDR, FBTR and all. So not more than this much is required in this thing. Nowadays the anti-knocking lead is not used as a anti-knocking. This is sodium and other additives are called added for this thing. So in biological, this is a potassium chloride used as a fertilizer. If you see the potassium chloride is a first is a fertilizer. Then potassium chloride is a good salt. It is used as in the potassium hydroxide is used in soft soap. That means the bathing soap, soft soap. Potassium is and then it is what you call wherever the carbon dioxide filtration is required in the DM plants and all. Potassium hydroxide used as a filter. That means it will not allow the carbon dioxide to solubilize in the DM water and make it acidic. There will be KOH pellets will be used for absorbing the CO2 in the DM plants applications and all. It will be used in the demineral water plants and all. So that is the most important requirement for the KOH. And the oxide will form with water will form the metal oxides. It means metal oxides will be in the water gives the hydroxides, and metal halides are the light melting colorless crystalline solids. So many metal halides are very useful in high negative therapies and all. Their melting point, boiling points are always the chloride, bromide tendency. Salts of oxo acids. But there is always remember there is a diagonal properties. That means in the first series lithium will be there. The second series is the beryllium. And the lithium will have the diagonal similar properties with like magnesium. And the beryllium will have a diagonal this thing like in the aluminum. Not the similar this thing, they have the diagonal this thing. Beryllium will have aluminum, lithium will have the magnesium more properties and all. Abnormal properties of lithium are some anomalies, small anomalies, not big. Lithium is much harder. That is the first one. Second one is lithium is the least reactive. Among the least reactive, but strongest reducing agent. Lithium. Lithium oxide, what you call Li2O, and lithium nitride, Li3N. Unlike it forms the sodium nitride and other things. Lithium chloride is the Demiquist crystalline. Lithium chloride. Other things will not form. Lithium chloride is not LiCl, but it is LiCl2H2O. Whereas other things will form not that much. Sodium chloride there will be small hydration, but whereas here hydration will be more. Lithium hydrogen carbonate is not obtained in the solid form, while other elements solid hydrogen carbonates will be there. Lithium nitrate will be forming, sodium nitrate it cannot form the two things. That is, suppose lithium nitrite, NO3, lithium nitrite. It gives the lithium oxide plus NO2 plus O2. Whereas the sodium nitrite, NaNO3, will not give sodium nitrate only NaNO2 only will be coming, and O2, but not this thing. Here oxide will not form. NaNO2 will form. Here it will be separate. So there will be small these things. And another one is both diagonal property, lithium and magnesium, and whereas beryllium and aluminum will form lithium chloride, magnesium chloride soluble in ethanol. Lithium chloride, magnesium chloride are delinquent, and lithium and magnesium gives monoxide, lithium oxide and magnesium oxide types. Lithium and magnesium reacts slowly with water. That means they have similar properties. Diagonal properties, lithium and magnesium will have same, beryllium and aluminum will have. Sodium will have the important, because sodium hydroxide is one of the most important of this thing. Sodium carbonate is more required. Sodium chloride, sodium hydroxide, more sodium compounds are there. So we'll say sodium tomorrow once again. More this thing. Thank you.